So in the last video we went over LU decomposition, and one of the problems that this decomposition had was that it isn't generally unique. If we think of L as a lower triangular matrix and U as an upper triangular matrix, then there's more than one pair of L and U that can satisfy or decompose A. Okay, so to solve this issue, what we did is think of L as a unitary triangular matrix, which means put ones everywhere along the diagonal. Okay, and start from here, solving the LU decomposition problem is even better because we don't have to do any multiplication or like the way we did it last time. We're not gonna work on that anymore. So basically, if we would like to decompose a matrix A into L and U, we carry on Gaussian elimination. Yeah, Gaussian elimination on A. And once we reach the reduced echelon form, we call this U, okay? Now, for L is gonna be basically having zeros here and ones along the diagonal, and then all the other elements are going to be the multiples which brought the corresponding element to 0 in U. Okay, I know this sounds confusing, but we'll work on an example and it will be clear now. So we have A equals 2, 3, 5, 1, 2, 4, 3, 2, 7. And yeah, we'll like to find an LU decomposition for that. So we start by carrying on Gaussian elimination, and this means I'm going to multiply the first row by -half and add that to the second row. Okay, and then multiplied by -3/2, and then add that to the third row. So by doing this, we're gonna get so 2, 3, 5 remains the same. This becomes 0. This becomes half. 5 becomes, so 4 becomes 1.5. Okay, and then here you get 0. 3 becomes, so 2 becomes -2.5, and then 7 becomes, so if we multiply this, oh yeah, it becomes -half. Okay, so we still didn't reach the row echelon form because we gotta get rid of this guy, and to do this, all we're gonna do is multiply row 2 by 5 and add that to row 3. So by doing this, we'll get 2, 3, 5. Second row also remains the same, and here's gonna be 0, and here now is gonna be also 0, and here's gonna be this is -half, there's gonna be 7. Okay, so yeah, once we reach this reduced echelon form, we can call this our U. And to find L, it's pretty straightforward. So to get this element of U, we basically multiply the first row by -half. So this becomes half. We always take the opposite sign. To get this element, we multiply the first row by -1.5. So this becomes 1.5. And to get this element, we multiply the second row by 5. So this becomes -5. So this is the unitary lower triangular matrix that we're talking about, and this is U. If we multiply L by U, you can try this. Of course, it's gonna give you back A. So it's -5, I guess, and this is 1.5. So sorry about the handwriting. So this is L. You multiply that by U. 0, half, 1.5007. You get back A. 2, 3, 5. 1, 2, 4, 3, 2, 7. Okay, now one thing about the LU decomposition is that it doesn't always exist. It would only exist if the principal minors of the leading principal minors of the matrix are not 0, and these are. So you start by taking the determinant of the whole matrix, and then this mini matrix, and then this one, and so on. So if any of this is 0, you cannot find an LU decomposition for your matrix A. So this is gonna be it for the video. I hope you liked it, and thank you so much.